Hello, welcome back at Ask the Professor. Here I'm sitting and enjoying the sunshine in this crisis of Corona, but okay, what can we do? I think we have to go on, and we can go on because this is really safe here in the park. I get out 3 questions from the fora and I really enjoy it. Other questions you can also share with your other students and find a question and also answering this play, you can do that yourself. One of the first questions was about what about the curves and how to make the right curves fitting to the right curve you need for a train when it goes through a switch. Through a switch, normally you could say, okay, I just make a curve, but then you have also your cant. And when you have cant and curve and you go to the straight track, you really have a problem how to connect these two. Therefore you have this transition curve, and normally when you look at the modern railways, it's just flat straight track. You go in a transition, that's just a straight line, you could say, and then we go into the cant. But that's not good. The real wheel-rail interface in the right connection, you really need a smooth transition zone, you could say, inside this. And why not build in this smooth transition in the switch? It's possible, but how to do it? Normally you can say, okay, we make, in the old days when we had ballast, you can say per sleeper you can make this building up. But when you look at today, everything with the tamping machines is done by laser. And a laser you cannot make a nice curved shape. So how to do it? Therefore we have to go back in time and look what our older people and also maybe know, but also what we had in the old days. In the old days we had a small pocketbook where you could see what you have to do and how to calculate the right clothes widths, who to do it and why to do it. And that's what we miss today. And that's because in the old days it was made by hand, and today it's more or less demanding or dictated by the machines. Machines are really great, really superior, but it is always straight. And how to make with the machine a nice curved, just tailor-made curve for a switch. Nice question, and maybe I like to put that question back to you. So how can we do that? Make it tailor-made, handmade, or make something smart with a new machine or new production techniques? So it's up to you. Another question I got was really nice about how the current go, for example, from the overhead for the catenary through the pantograph into the train. Then you could say when we have a roller pantograph, you have also the bearings, you could say, and how this current flow through the bearing and then go to the train itself. Therefore, you need very special techniques that there is no welding during this process, because we talk about a lot of current, high amperage, and how to manage this. You could say this is the same idea on the wheel-rail interface, because over there you also have go through a roller bearing, and also how to connect to the wheel, you could say as a bearing itself, and also how the current go into the flow, into this real contact patch. It's not that easy, but it works. And I think the secret is, it's no problem when you have enough cross-section area. Then it's no problem, because a huge area, then the current is in general very low. So there is no problem that it will weld together or that you get problems. So when you have only one spot, for example a very small ball, and you put there 1000 amperage through, then you weld it together, and that's the problem. So that's also the answer, how to manage the right amperage with the right section area, square areas, and then you can say, okay, this is enough or not. Another question was about what is the relation of hardness between the wheel and rail interfaces. Is there a relationship, and how does it work? I think it's very clear, there is definitely a relationship, because when you have hard rails, you have a higher resistance against wear. But also, you need the same mechanism on the wheel side. But how does this keep that in balance when you have both going hardening the wheels and the rail? Then you are the same question or the same problem. So you have to be really secure and also be keen how to manage this in the right way. So you always have the problem of getting high stresses, so you get cracks in your steel, or you get wear. And that's because of the hardness, because you have low resistance against wear, and therefore you get wear. So what do you like? And that's typical on what system you work in your own country. When you have, for example, low costs of steel and low costs for example, for how and easy to exchange wheels or rails and really cheap labor, you could make a choice for, okay, then I take hard wheels and softer rails, so the wheels will survive and the rails will wear worn away, but that's no problem, because your business case is, I like to have wear that's easy to manage and also cheap. But for example, in Holland we have the opposite. It's very difficult to take out some new parts because of wear, and how to manage this. Then you can say, I need very hard rails, so the wear as a resistance is there and we only get stress problems, no wear problems. That could be helping us to say, why not making a little softer wheels, because the wheels are easy to take out and turning in a new profile every time. So that's always a balance. What do you need? Is always, you get pain, you get or wear, or you get really stresses, and what do you like and how to make the choice. Okay, that's it for this week. Hopefully you really enjoy and you get some knowledge out of these questions. So keep alive and stay healthy in these times. See you next time. Keep on track.